All right, we're going to take a look at the next set of part 3 and 4 questions on the June 23 regions. So we're on page 226, and we're going to look at question 32. All right, so Cape Canaveral, Florida is where NASA launches rockets into space. As modeled in the diagram below, a person views the launch of a rocket from observation area A, 380 feet away from the launch pad B. After launch, the rocket was sighted at C with an angle of elevation of 15 degrees. The rocket was later sighted at point D with an angle of elevation of 31 degrees. Okay. So we want to determine and state to the nearest foot the distance the rocket traveled between the two sightings CD. So we're gonna need to find that part. Okay. Now this is a SOHCAHTOA question, and as I've told you guys a bunch of times, when you see these overlapping triangles, this type of diagram, the easiest way to kind of think about it is to separate the triangles. Okay, so I'm going to separate the big one, so ADB. And then ACB. Okay, so this is 31 degrees, 15 degrees. This is 328, 80 feet, and this is the same. Now the length of DC is equal to the length of DB minus CB. Okay. I'm going to call this X and I'm going to call this Y. So we have to do SOHCAHTOA 2 different times for us to find X and for us to find Y. So let's start with X first. So this is my person. So this is my opposite adjacent. So we're going to use tangent here. So tangent of 31 is equal to X over 3,280 feet. So X is equal to 3,280 tangent of 31. So I'm just going to leave it like that for right now. Now I'm going to solve for Y. So same thing. This is my opposite. This is my adjacent. So tangent of 15 is equal to Y over 3,280. Now we're going to cross multiply. That's what I did over here. So that's what I'm going to do over here. So 3,280 times tangent of 15 is equal to Y. Now, as I talked about right up here, so the length of DC is equal to the length DB minus the length of CB. So if DB is X and CB is Y, DC is equal to X minus Y. So to find the length of DC, we're going to do 3,280 times the tangent of 31 minus 3,280 times the tangent of 15. Okay. So let's put all of that into our calculators. So we get 3,280 tangent of 31 minus 280 times the tangent of 15. So we end up with that. So DC is equal to 1,091.949479. Now we want to round to the nearest foot. So the nearest foot, the length of DC ends up being 1,092 feet. Okay. All right, so let's take a look at question 34. Okay. So parallelogram math has vertices M, A, T, and H. We're going to first prove that the parallelogram math is a rhombus. All right, so let's first plot these points, and then we're going to talk about what a rhombus is. So M is -7, -2. 2. And A is 0, 4. It's H. So let's draw in the rhombus. So let's go back to proving a rhombus. So remember, a rhombus is a parallelogram that has either perpendicular diagonals for congruent sides, so to prove that it's a rhombus, obviously we need to prove that it's a parallelogram, but then we need to kind of go a step further and prove that there's either perpendicular diagonals or there's four congruent sides. Now, if we start, now there's kind of different ways that we can go about this. Now, remember our four ways that we can prove a parallelogram. So we could do either opposite sides are parallel, opposite sides are congruent, diagonals bisect each other, or the same side is both congruent and parallel. Now, obviously, you can choose any one of these four ways to prove that it's first a parallelogram, but let's kind of think about what else we have to do. So to prove that it's rhombus, like I said, we have to either prove that the diagonals are perpendicular or that there's four congruent sides, okay? What I'm going to do is choose this method, so choosing the method that opposite sides are congruent, because if we do the distance of the four sides, we can show that all four sides are equal, and that's kind of saves us a little bit of work. Okay, so I'm going to do the distance of MA, MH, AT, and TH. Okay, so let's do the distance of MA. So we have -7 minus 0 squared plus -2 minus 4 squared. So -7 squared is 49. And then -2 minus 4 is -6. -6 squared is 36. So 49 plus 36 is equal to the square root. We have the square root of 85. All right, so now let's take a look at MH. So MH, so we have the square root of M, the x coordinate for M is -7, so -7 minus 2 squared plus -2 minus -4 squared. Okay, so -2 minus 2 is -9, -9 squared is 81. Plus -2 minus -4 is 2. 2 squared is 4. So we get the square root of 85. Okay, so let's now do the distance of AT. So AT, we're going to do 0 minus 9 squared plus 4 minus 2 squared. 9 squared is 81. Plus 4 minus 2 squared is 4. So we get the square root of 85. Okay, and now let's do the length of TH. So 9 minus 2 squared plus 2 minus -4 squared. So 9 minus 2 is 7. 7 squared is 49. And then 2 minus -4 is 6. 6 squared is 36. So now we get the square root of 85. Okay. Now remember, when we do coordinate proofs, we need a statement. So we need a statement saying why this is a rhombus. So MATH is a rhombus because all four sides have equal lengths and therefore four sides are congruent. Okay. Now let's take a look at the second part of this question. So the second part of this question wants to state the area of math. Now, for this part, we're going to need to do the box method. So what the box method is, we draw a rectangle around this whole thing. Okay. Now, the area of the rhombus is the area of that rectangle minus these four little triangles. So I'm going to call this triangle number 1, triangle number 2, triangle number 3, and triangle number 4. Okay. So let's start with the rectangle. So the area of the rectangle is equal to, so this side is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 units. This one is 1, 2, 3, 4, 5, 6, 7, 8. Just double check. Okay, so 16 times 8. Okay, so now we want the area of triangle number 1. So the area of triangle number 1. So this is 1, 2, 3, 4, 5, 6. 6 units. This is 1, 2, 3, 4, 5, 6, 7. So 1/2 6 times 7. The area of triangle number 2 is 1, 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2. And then triangle number 4. So this is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Okay. So let's kind of simplify this a little bit. So 16 times 8 is 128. The area of triangle number 1 and triangle number 4 is 21. And then triangle number 3 and triangle number 2 is 9 and 9. Okay, so my total area of the rhombus is 128 minus this plus this plus this plus this. So 21 plus 9 plus 9 is 60. So my area is 68 units squared. Okay. All right, so last one, we're gonna look at question 35. Okay, so we are given quadrilateral ABCD. AB is congruent to CD and AB is parallel to CD. We have diagonal AC intersects EF at G and DE is congruent to BF. Now we want to prove that G is the midpoint of EF. Now, a midpoint, remember, cuts a segment into two congruent pieces. So if G is the midpoint of EF, then EG has to be congruent to GF. So to prove this, we need to kind of prove this is true. Okay, so let's start off, as we always do, with our statements and reasons. Okay, So statements, first thing we want to start off with is quadrilateral ABCD. Our second thing is AB is congruent to CD, and AB is parallel to CD. So I'm going to just write that in one line. Okay. And then DE is congruent to BF. All right, so let's kind of take another look at what we have to prove. So we have to prove this, but in order to prove this, we have to prove this. Now, in order to prove this, we have to prove that two triangles are congruent first. So EG and GF are part of these two triangles. So we're going to have to somehow prove that EAG is congruent to FCG. All right, now let's think about our first two givens. Our first two givens is quadrilateral ABCD.
Do you mind just...
So we have quadrilateral ABCD, and we have AB is congruent to CD, and AB is parallel to CD. So remember, when a quadrilateral has the same sides, both parallel and congruent, it is a parallelogram. So before we go any further, we should say that ABCD is a parallelogram. Okay, so if a quadrilateral has both the same side, both congruent and parallel, then it is a parallelogram. Okay. All right, but the fact that these are parallel and congruent does not help us prove that these two triangles are congruent. Okay. Now, because this is a parallelogram, we know that both pairs of opposite sides are both parallel and congruent. So now what I'm going to say is that AD is congruent to BC and AD is parallel to BC. So in a parallelogram, both pairs of opposite sides are both congruent and parallel. Okay. So now we know that this side and this side is congruent and parallel. Okay. Now we're trying to get these two triangles congruent, so we need AE congruent to FC. So now we do know that BF is congruent to ED, and now we know that AD is congruent to BC. So now I'm going to do subtraction property to get AE congruent to FC. So we have AD, and we're going to take off ED, and that is congruent to BC minus BF, or that is equal to, congruent to AE and FC. So now we have AE congruent to FC. So this is going to give me a side. Okay, so now we need to look for some angles. So we have a side, now we need to look for some angles. Now these two are parallel, like we said. So now I can say that this angle is congruent to that angle because they're alternate interior angles. So now angle EAG is congruent to angle FCG, because if two lines are parallel, then alternate interior angles are congruent. Now, we need to look for another angle. So this is going to give me an angle. Now, these two, remember, are vertical angles. So now you can say that angle AGE is congruent to angle FGC because vertical angles are congruent. Okay, so now we have a side, we have an angle, now we have another angle. So now we can say that these two triangles are congruent. So EAG is congruent to triangle FCG by angle, angle, side. Okay. So now that we said that these two triangles are congruent, so now we can say that this is congruent. This is true. So now we can say that EG is congruent to GF by CPCTC. Okay, so now we've said that. Now we can say what we really need to say is that G is the midpoint of EF because a midpoint is a segment into two congruent pieces.